material. The ice and rain protection systems allow for operation in heavy rain and icing conditions. Depending on the component, protection is provided either through the use of bleed air or electrical heating. Windshield wipers are located on each pilot's windshield for rain removal. Controls and indicators for the ice and rain protection systems are located on the overhead anti-ice panel. The systems may be monitored by referencing the memo section of the EWD and the bleed page. The engine anti-ice system prevents ice formation on the leading edge of the engine nacelles. An independent bleed air source from the high-pressure compressor heats the engine nacelle leading edge. Engine bleed air does not have to be selected on to use engine anti-ice. Engine anti-ice must be turned on during all ground and flight operations when icing conditions exist or are anticipated. Engine icing conditions exist when the outside air temperature is 10 degrees Celsius or below and visible moisture in any form is present. The Engine 1 and Engine 2 push buttons on the overhead anti-ice panel control the respective engine's anti-ice valve. When the lights in the Engine 1 or 2 push buttons are extinguished, engine anti-ice is off. When the Engine 1 or 2 push button is selected on, the blue on light appears, and the amber fault light illuminates briefly while the valve is in transit. In addition to the lights illuminating in the push button, when the Engine 1 or 2 push button is selected on, the following occurs. The engine's N1 limit is reduced. The engine's idle speed increases. A green engine anti-ice memo displays on the EWD, indicating that an engine anti-ice valve is open. And continuous ignition is automatically activated for that engine. On the A321, continuous ignition is not activated when engine anti-ice is selected on. Wing anti-ice may be used to either prevent ice formation or to remove ice accumulations from the wing leading edges. Specifically, hot bleed air provided by the pneumatic system is used to heat the outboard 3 wing slats. Wing anti-ice should be selected on whenever there is any indication the airframe is accumulating ice. Indications of airframe icing can be seen on the visual ice probe or on the windshield wipers. Wing anti-ice may be used both with the slats retracted or extended. However, wing anti-ice capability is reduced with the slats extended. Therefore, prolonged flight in icing conditions in this configuration should be avoided. The position of the wing anti-ice valves are controlled by a single push button located on the overhead anti-ice panel. When wing anti-ice is not in use, the push button is off, lights out. The blue on light appears, and the amber fault light illuminates briefly while the valves are in transit. In addition to the blue on light illuminating in the push button, when the wing push button is selected on, the following occurs. The engine's N1 limit on both engines is automatically reduced. The engine's idle speed increases. The wing anti-ice memo appears in the EWD memo section, and the anti-ice indications appear on the bleed page. If the wing anti-ice push button is selected on while on the ground, the wing anti-ice valves open for a brief test sequence. However, after a short time, the valves automatically close, and the anti-ice indications disappear from the bleed page. A structural ice indicator is located on the exterior of the center windshield post. The indicator can be viewed from either pilot position within the flight deck. The two windshields and 4 side windows are electrically heated to provide anti-icing. 2 independent window heat computers automatically regulate the system and provide overheat protection. Window heat can be applied either automatically or manually. Window heat is activated automatically by the window heat computers when the probe window heat push button is in the auto lights out position. The windshields and windows are heated when at least one engine is running on the ground and whenever the aircraft is in flight. You can manually activate window heating by selecting the probe window heat push button. When selected, On illuminates within the push button. This overrides all auto logic. The system will not revert back to auto logic unless the push button is manually selected back to auto lights out. Each windshield is equipped with a 2-speed electric wiper. The wipers are controlled by a 3-position wiper rotary selector. The maximum speed for operating the windshield wipers is 230 knots. The probes, pitot tubes, and static ports are anti-iced to ensure that they remain open in order to provide accurate data to the Air Data Inertial Reference System. Electrical heating is provided for the following: pitot tubes, static ports, total air temperature probes, and angle of attack probes. Three independent probe heat computers automatically control and monitor the system. One computer controls and monitors heating for the captain's set, another for the first officer's set, and one for the standby set of data sources. The total air temperature probes are not heated on the ground to avoid inaccurate readings during ground operations. Pitot tube heating operates at a low level on the ground and automatically shifts to a normal power level when in flight. Probe heating is activated automatically provided the probe window heat push button is in the auto lights out position. Heating automatically activates when at least one engine is running while on the ground and whenever the aircraft is in flight. Probe heat can be activated prior to engine start by pressing the probe window heat push button. When selected, the on light is the only flight deck indication that probe heating has been manually activated. Once the engines are started, you will have to deselect the push button to return to automatic system operation. This concludes the Ice and Rain Protection core material.